At one point in time, and it's difficult for me to point when, because I'm not a student of the business of implantology, a bolt of lightning struck this field, and that bolt of lightning, in my opinion, was named Jerry Niznick. And he reversed all the bad things about what I just mentioned before. With honesty, integrity, toughness, good business skills, etc. And who are the beneficiaries of Jerry's work? They are us having low-priced, fair implant systems that have good success rates and the patients that we serve. So if he doesn't mind being called a bolt of lightning or a flash of honesty coming on this field, that's really how I feel about what Jerry has done for us. Now, I don't endorse any implant system, so this is not an endorsement. It's really talking about the character, and I don't mean being a character, but the moral character and the integrity of Dr. Niznick. And it's my pleasure to introduce him to you tonight, and my pleasure to sit here and listen to him. Jerry, thank you so much for what you've done for this field.
I appreciate his generous comments and his leadership. When I got started in implants back in 71 or 72, Ken was an authority in implants even at that time, and I would come and ask him things if I wanted a straight story. So Ken, thank you very much. It's nice to see you here with me in New York, and thank all of you.
Let's talk about osseointegration, 30 years of innovation that I've been involved in. You can go back to 1982 with the introduction of the Corvent. It was really the first implant that was ever used freestanding to retain an overdenture. That's become minimum standard of care now for the American College of Prosthetics. The Corvent had bendable heads, cemented heads, very simplistic approach, but it brought versatile prosthetics to the industry. Here's a 27-year follow-up of a Corvent implant with a bar overdenture. 1986, I introduced the ScrewVent implant with the internal connection, and we're talking now 25 years later, this ScrewVent, straight ScrewVent with this connection and these threads are still being sold. What other implant is still around 25 years later? It evolved over the years, changing the size of the vent a little bit, until finally in 2000 I introduced the tapered screw vent. Now I knew that when I made a tapered implant I didn't need a vent. A vent is there for a straight implant. When it first cuts the threads in the bone, it needs a place to drop the chips. With a tapered implant, that narrower end is not touching anything until the final seating of the implant. So why did I leave the vent in the tapered screw vent? Because screw no vent would have been a bad name for an implant. But with my new implants, I've eliminated the vent. It's not necessary. This implant came in a blasted surface, blasted with HA crystals since 1992. We haven't changed the surface. It's the same surface as Zimmer uses and BioHorizons. We also offered HA coating options, and the implant had a 1 millimeter machine neck. To this day, Zimmer is selling it with the machined neck. So this slide shows the evolution of the screw vent up to the tapered screw vent in the year 2000. Here's a picture of our current factory. We have 40 machines. We maxed out on the floor. You can go on the website and watch these machines operating 24/7. We're the only company that set up the machines to run automatically without anybody in the building. So our final shift goes home at 10 o'clock. It runs all night. It runs all weekend. And that's because we had 2.5 years to figure out how to program and get these machines to run non-stop. It took a lot of different aftermarket devices on the machine to make that work. We offer a very broad line of implants and abutments. Here you see the Legacy 2, which is our most aggressive threaded implant. It's straight for the top third, tapers, and with the inside threads tapering at 5 degrees and the outside tapering at 1.5. It has 3 cutting grooves that go 2/3 of the way up. So that's our more aggressive one. We have a Legacy 1, 2, and 3. We'll be talking about them. On this side, we have the Reactive, which is a evenly tapered implant, again with the threads getting progressively deeper, with 2 cutting grooves going halfway up. This is the same body as on our Legacy 3 implant, but this one has a Nobel tri-lobe connection, whereas the Legacy 3 has the screw vent connection, the lead-in bevel internal hex. We also make compatible implants. This one is the Replant, which is the same body shape as the Nobel Replace implant, goes in with all their drills. Both of these have the tri-lobe platform, and all the abutments that go with these implants work with Nobel. This is our latest implant called the Swish Plus, which will be launched next month. Completely surgically compatible and prosthetically compatible with Straumann. It has the same straight body as Straumann. I've made the threads progressively deeper. I've added micro grooves there. And it comes on a fixture mount that's quite interesting. We also have application-specific implants. This is the Go Direct one-piece with an attachment like the locator abutment on the top. And this is a one-piece implant with a multi-unit abutment on the top for bar overdentures, and a full line of prosthetic components for every one of these. We now have overdenture attachments that accept the locator cap attachments, although we have our own, and these come angled, whereas the locator is not available angled. A recent article by European Bank noted that there are a variety of discount implants, but Implant Direct has moved out of the pack towards the group of the more established, larger companies. And it says, it also illustrates the rise of Implant Direct, which is, in our view, more than a so-called internet discounter, and is moving towards the pack of value premium players, albeit at a significantly lower price. So we've had to focus on quality and precision, which I've always wanted to do and always did, but I knew that if I came back in the market undercutting the price of the Nobel, Straumann, Zimmer, BioHorizons 3i products by 65 to 70%, they were going to be looking for things to criticize. So we focused on making the best quality and precision in the industry. And a magazine wrote an article on us calling us the shop of the future. This is just one of our implants with an external bevel showing the precision between the threads and the margins. But not all implants are created equal. This is an implant that I bought in Israel about a year and a half ago, and it shows burrs on the implant, so we took pictures of that. This was the precursor of the Nobel Active. Nobel now owns this company in Israel. It's called Alpha Bio, and Nobel took their design and introduced it as the Nobel Active implant, and I hope they've cleaned up their manufacturing quality since then. So we have expanded first to 40 machines, and now we've started construction on a new factory that will house 28 more screw machines. We're already committed to 54, going up to 54, so we have the capacity to make prosthetic components, CAD milled bars, zirconia abutments, eventually custom abutments. We have a packaging facility in Las Vegas. We're building a 4-chair dental office and a 50-person high-tech teaching center there. There'll be computers at every desk, and we'll be teaching our image-guided surgical programs there. We have a beautiful office in Zurich as well, and in Canada and Israel. Now, when I started to build an internet-based company, I knew that I needed excellent customer support through the internet. So we developed the most intuitive shopping cart and 3D graphic videos that explain every procedure. This is our customer service building with probably 60 people there. 40 of them are paired, and we had 33 when this slide is prepared. We're up to 40 now. We try and pair an inside person with an outside person. Some of the pictures from the website, it's graphic driven. Some of the pictures showing all the videos that are available. Here's the shopping cart. Very easy to pick the system that you want. If you press the prosthetic button, you can go right to the abutments that you want, surgical trays. This will show you the implants that we have. Now I want to hone you in on what implants to use, because while you say, well, they've got 12 implants, it's confusing, you can get by with 1, 2, or 3 of these implants. This system is called the Spectra system. There's 6 different implants, all priced at $150, all with all-in-one packaging, which includes the abutment and the transfer, and in some cases the healing collar where appropriate, comfort cap. So we have a screw plant, which is your basic 2-stage implant, a screw plus, which is the same body implant but with a 2mm neck extension, a screw direct 1-piece implant. Where would you use that? It comes in 3mm diameters. You can use it in narrow areas. You can use it in a freestanding lower bicuspid or molar where parallelism is not an issue. This is the screw indirect with the 1-piece implant with a multi-unit abutment on the top. We'll be showing you cases on this. It's the 1-piece implants that you see here. These 4, they can make a 1-piece implant down to 3mm and have strength. So these 2 come in 3mm, and the Go Direct over here with a locator type top also comes in 3mm diameter. We even have a 1-piece implant with an angled head and a contoured margin for upper laterals, 12-degree angle. You say, well, how do I know what angle I'm going to put it in? Well, we have guide pins, angle guide pins, so after you make your pilot drill and put the angle guide pin in, if this is going to work, fine, you don't need to buy an abutment. If it doesn't, then don't open the package and go right to a 2-piece implant like the screw plant. We have 3 implants with tri-lobe connections on them. The Replant implant, completely compatible with the Nobel drills. It's shaped and dimensions the same. Then we have the Replus, which is the body of the screw plant, also the same body as the Legacy 1, but with a tri-lobe connection. And then we have the Reactive, which is the same body as the Legacy 3, more aggressive threads, but the same even taper. Now, all of our implants are made of titanium alloy for added strength, and these 2 implants have the dimensions of the Spectra system and Legacy. In other words, instead of a 3.5, this goes to 3.7, and the platform tapers back to 3.5, so you get an added strength there. And the Swish plant implant, which we've had on the market for a year and a half, works with Straumann drills, has a Straumann platform, and we're going to be introducing an even more compatible implant called the Swish Plus. So here is the Legacy 1, 2, and 3. Now these are rapidly becoming the most popular implants. Legacy 1, 125, Legacy 2, 150, Legacy 3, 175. This comes on a plastic carrier. This comes on a titanium carrier that can be used as a transfer or shortened as a temporary abutment. Legacy 3 can be shortened for a fully preparable abutment. And it's sort of a mix and match thing. If you buy this implant and then decide you need an angled or custom abutment, save the fixture mount. Next time, buy the $125 implant and use the fixture mount with it. This has more aggressive threads, and this is even more aggressive for expansion of soft bone for initial stability. There's only 3 things that are critical in achieving osseointegration. Avoiding overheating during bone preparation. Not a problem with our drills. They're sequential cutting step drills that step up a ½ millimeter at a time, so you don't need internal irrigation. We're just shaving a little bit of bone away each time. Achieve initial stability. If you get to 35 Newton centimeters of initial stability, you can immediately temporize the implant. So what differentiates implants today is how much stability can you get in soft bone. If you have to use a bone tap, you may not even be stable in dense bone. You could oversize it with the bone tap. So we don't make bone taps. All of our implants are self-tapping, and because we're using the original screw vent surgical protocol of putting a tapered implant in with straight drills, we can expand the bone in soft bone and increase this stability. And finally, avoid premature loading beyond the implant stability level. Today we know if you can get to 35 Newton centimeters, or if you're splinting 2 or 3 implants, that you can probably put the implant into light function or temporize it at time of placement. This is a picture of this almost became the logo of the Nobel system. It was an osteoblast extending its cell processes over the titanium. Appears on the cover of Brånemark's new textbook. It was from an article in '83 by Brånemark and Albertson showing SEM of an osteoblast from a upper jaw implant. But I found an article a year earlier where the same SEM was a fibroblast from soft tissue around the ear. So you might say that osseointegration has its roots in deception. And I sent out brochures when I discovered this. Osteoblast or fibroblast, I'm confused. And that didn't stop them from still using this phony picture. A variety of implant surfaces. Companies used to differentiate their products based on the surfaces. Oh, our surface is better and you get faster healing. The Brånemark was the first one to do that. He even patented a machine surface and then sued a number of companies to try and stop them. Sued us, sued 3i. His patent was eventually declared invalid by fraud on the U.S. Patent Office, and Nobel had to pay 3i $15 million on that. 3i acid etches their implants, something that Stereos started, that I followed because it's a great way to clean the surface. But we eventually found out that it makes the surface too smooth. So all the companies have moved away from acid etching. Companies like Straumann will blast with aluminous oxide and then etch to get the aluminum particles off, but that blasting followed by etching tends to round the threads. So most companies have have stopped using acid etching. HA is very popular in some circles, and research shows it's really the best surface for bone attachment. I'll show you some studies. Nobel uses a tiunite anodized surface or oxidized surface. It can only form on pure titanium, so they're locked out of using the stronger alloys. This is the surface that we use, LifeCore BioHorizons, and this is Straumann's etch surface. Astra blasts with titanium oxide and then etches with hydrofluoric acid to get those particles off. So the point is, don't differentiate an implant by the surface. Any good rough surface, clean rough surface, is going to work equally as well. Here's a study when we were acid etching our implants. We were putting TPS surface on them. We were also blasting them, and we had HA. We had 4 different surfaces at one time. The etched smooth surface was consistently the worst. The TPS, which was a very rough surface in our blast, and HA was about the same for 1 month, but by 2 months, the HA had doubled its attachment strength. This is just showing our HA. We still blast the top micro threads and put HA on the bottom for those that want it. And you can see a close-up. The texture of the blasted surface is about the same as the HA surface. Very dense HA material. Funded a study in the 90s called the VA study, 1,000 patients, 3,000 implants, and that was pitting HA-coated implants up against acid-etched. In dense bone, there was a 97% success with HA and 91 with non-HA or the etch surface. When you got down to type 4 bone, the HA had only dropped 2 percentage points, but the acid etch surface implants were down to 25% failure. That's when I stopped acid etching. It was just too smooth. And also they looked at, compared experienced with inexperienced clinicians. Those that had placed 50 or more were considered experienced, 50 and less were inexperienced. Overall, there was only about a 1% difference. With non-HA, though, there was a 3% difference. So HA is a little more forgiving. In 2000, I published an article, Achieving Osseointegration in Soft Bone. And what all this was about was taking our tapered implant and putting it into a socket using straight drills to increase the stability, put it under compression. This video will show you what we're talking about. So assume this is soft, spongy bone, and assume this is denser bone. With the soft bone, you'd go in for a 3-7. You'd stop with the 2.8 drill, which steps down to 2.3, so the narrow end of the implant would engage, and you start compressing and expanding the bone. And we've got the dimensions of these drills and the taper of the implants just down perfect to know how much compression will result. In denser bone, you could stop at a 3-4 with the stepping down to 2.8 and screw the implant in. When you think about it, a 3-7 implant going into a 3-4 hole, there's only 0.15 millimeters of thread engagement. So you can self-tap that implant in, especially if it's made of alloy, and you can put enough strength on it, enough torque. Another thing I developed was multi-lead threads, triple lead on the screw vent. Today we use double lead, and it just means the implant will screw in faster. So here it took 20 turns to accomplish what you could do in 7 turns with the multiple lead threads. And when you put the implant into soft bone using the undersized drill, you got up to 8 inch-pounds of torque versus 3. A animal study was subsequently done by somebody in Europe, and he confirmed that surgical technique has a decisive effect on implant fixation, represented in the study by installation torque value, removal torque, and histomorphometric. So it's harder to screw it in, we understand that. After it integrates, it's harder to remove, and there's a higher percentage of bone contact if you put soft bone under compression. Dr. John Cavallero is here with us tonight, and he recently published a study of, I think, 204 screw plant implants where he documented 99% success. There were some legacy implants in that study as well. And I'll quickly go through his results. He presented this at European Symposium. It's since been published. He had 99.4% survival of implants placed in heel sites. He had 1 failure for 96.4 in immediate sockets. Overall, 99% success. That's initially. Surgical insertion at 1 year. Bone is at the coronal aspect of the mini threads. Never lost bone below the mini threads. And this is measuring the bone loss. The first millimeter of the implant above the mini threads is blasted, so we lost 3/4 of a millimeter in the first 4.5 to 6 months, and then by 12 months, still under a millimeter of bone loss, and each year thereafter, less than 2/10 of a millimeter of bone loss. Without platform switching, he experienced under a millimeter, 0.96 and 0.83, and this is at 6 months, this is at 1 year. And for an overall survival of 99.43%. I think, this is measuring the bone with platform switching. Some of our abutments come short of the margin, and some people believe that reduces crustal bone loss, and he documented that in fact it did by about 2 or 3/10 of a millimeter. The VA study placed 3,000 implants, and before they inserted the implants, after they had drilled the hole, we measured the labial plate and recorded it, buried the implants. When we uncovered it, we correlated bone loss that had occurred submerged with how thick the labial plate was at the time of implant placement, and there was a direct correlation. If we had a 0.5 millimeter of labial plate, you'd lose 2 millimeters of bone. 1 millimeter, you'd lose about 1 millimeter to a 0.5 millimeter. 2 millimeters of labial plate, you wouldn't lose any bone. So we hear a lot about this platform switching, and there's some studies that indicate a little difference, but in reality, you lose bone based on how thick the labial plate is, and it's an insignificant amount. Looking at the fit of the margins and the stability of the joint is critical. A lot of this bone loss, early bone loss, was due to external hex implants that had 6 degrees of rotational instability. We're down to less than 1 degree. Here's some video studies. This is online, a German study from Freiburg University, and they looked at a number of different implants. This one is the Bago implant, which is like the screw vent. It's a copy of the screw vent connection, lead-in bevel and internal hex. Very little, if any, micro movement there. This is the Nobel butt joint connection. You can see that this does gap more. We know from Crown Bridge that you don't necessarily want to make a butt joint if you can make a chamfer margin. And Camlog was actually the worst in this study. That's a butt joint with 3 small trilobes, and you can see the amount of gapping. So there is a difference in the design and connection of the implants. What I focused on is innovation with a clinical purpose, and I'm going to go through some of our developments. The Legacy 3 implant has expanded now to 6 different diameters. The Legacy 2 also has a 7 millimeters, so within that system there's 7 different diameters from 3.2 to 7 millimeters. Soon we'll have our 6 millimeter implant on the market. So the Legacy offers the broadest product line. We have micro threads, which we'll be talking about, a broad prosthetic line, and a good selection of small diameter implants, not mini implants. The FDA will approve an implant for permanent implantation if it's 3 millimeters or above. And I don't see any purpose to make an implant smaller than that because it just becomes a pin. You need to use more of them. It doesn't have enough diameter through the emergence profile to give you the right prosthetic platform. So we have a number of 3 millimeter implants. Here's the micro threads that we have on our implant. We have double lead threads at the bottom fading into quadruple lead threads. I received a patent on this. Quadruple lead threads going to double lead, meaning we start at 180 degrees, and up near the top we start at 4 different points. Now, the importance of micro threads versus micro grooves is for stability. Here's a maxillary sinus case, and you can imagine all of this is in sinus graft. What's holding that implant? The top 3 millimeters. If you didn't have micro threads there, you wouldn't have anything stabilizing it. So micro threads are an important addition for stability. Here's another sinus elevation case through the socket. Now, Astra was the one that popularized micro threads. They run theirs to the top. Theirs is only a quarter the depth of the body. Mine are half the depth, and that's because they go from a single lead to triple lead, and if they went any deeper, they'd get into more cross-threading, or they couldn't keep the same pitch. Their marketing is time to challenge old truths. They claim they get 0.3 of a millimeter of bone loss. Remember what I said? Bone loss relates to how much crestal bone you had when you started out. We've proven that. and they compare against the old 1980s Bronnemark machine surface implants to try and claim a superior preservation of bone, which I think is kind of misleading. So you can see they have minimal threads. They have this long conical connection with a 12-sided internal surface. Here's the patent that we had issued. And here you can see our micro threads are half the depth. They show up on x-rays. The Astras don't even show up on x-rays. Other companies have come along and put laser lines on the implants, claiming that that's the secret to preserving bone or soft tissue attachment. This is BioHorizons. They have 12-micron laser lines towards the bone and 8 microns towards the tissue. And they have a tapered implant. They have the old Mish deep threaded implants, but they've now put this laser line on everything, and they're even putting the laser lines on the abutments, which should be like Velcro to plaque. But it won't give you the stability of a micro thread, and you've got enough texture here to compensate for anything this may claim to accomplish. In fact, there's a study published where they looked at various micro grooves. They tested 15, 30, and 60, and concluded the study indicated that titanium substrata with etched micro grooves 60 microns in width and 10 microns in depth significantly enhanced human gingival fibroblast adhesion. So 8 to 10 doesn't do very much. So what I'm trying to point out is there are innovations, but do they have any clinical significance? Here is the Astra implant going from single to triple. So the bone, the bottom of the implant cuts the threads, and then these micro threads follow along where the threads are already cut. So every third one lines up, and the other two just fall and crush the tip of the bone thread. With going from 2 to 4, we got a patent issued because we demonstrated that was the ideal configuration. Every other thread will follow with the bony threads that's been created, and the alternate one will cut a new thread in the tip. Here's the legacy system. This is the legacy 3.2. Adequate strength because we went to a 2mm hex hole, not a 2.5, but in order to get enough torque, we put a 2.25mm hex up at the top. Micro threads. Here's the legacy 4.2, legacy 3, cutting grooves halfway up, progressively deeper threads, and this does have platform switching because it's the 3.5 platform with a 4.2 body. And these are the 6mm implants. Without a vent, we can make a 6mm implant, and we designed it to optimize surface area. Our Legacy 3 4.2 has 102 square millimeters of threads. Straumann's 4.1 has 68, so we're at 40-some% higher. Here is the Bicon implant that focuses on short implants, and they have 76 square millimeters. So we're going to be able to optimize the surface area with a 6mm implant that has initial stability. This is the Legacy 2 implant with the more aggressive threads, straight for the top third, same 4.2 platform switching on this particular diameter because it's a 3.5 platform. Here the cutting grooves go 2/3 of the way up to the straight area, and we have 3 cutting grooves instead of 2 on this implant. So you can place this 4.2 implant into a 2.8 hole in the maxilla. It'll cut its way, it'll expand its way, and get you tremendous stability in the softest bone. Here's the 7mm Legacy 2 implant, primarily for immediate placement in molars. The bottom half of the 7mm implant is 5.7 diameter, matching the diameter of the 5.7 Legacy 3 implant. The target area of available bone is the septal bone between the two roots. Good way to initiate this surgical procedure is to flatten the remaining crown structure and start your osteotomy through the pulp chamber. Here we have a 2.3 initial pilot drill. Establish the depth of penetration. You can see the septal bone has been penetrated. Follow this with a 2.8 millimeter diameter step drill. The depth will be established using magnified schematics or sequential x-rays. Separate the molar into two segments and remove the mesial distal roots separately, being careful not to break the labial plate. A flap is optional, but usually not needed in this situation. Continue to enlarge the socket with a 3.4 drill and then a 4.4. We're preparing the size of this osteotomy to accept the 5.7 millimeter diameter apical half of this 7 millimeter implant. And finally, the 5.4 drill, which is the drill used for dense bone preparation of a 5.7 implant. If necessary, you can use a crestal bone drill to enlarge the osteotomy to 7 millimeters. Insert the implant, positioning the flat of the fixture mount to the buccal. If initial stability of 35 Newton centimeters or greater has been achieved, a temporary abutment could be attached, although in the non-aesthetic zone it is more likely that you will just attach a extender and cover screw to maintain the tissue opening. This slide shows the wide variety of abutments available for the 5.7 platform of the 7 millimeter Legacy 2 implant, including a plastic temporary abutment. And here a dentist placed a 4.2 into the septal area and required then a lot of bone grafting, but he does this on a routine basis, Italian dentist. If he'd had the wider implant, there would have been less bone grafting. Here's a case where the dentist, before he took out the tooth, established the position and the angle, and then beautifully placed the 7 millimeter implant along with a 3.7. Mini implants for teeth in a day. This is the ideal implant for that, a one-piece implant, 3 millimeters. Also comes 3.7. Most of the time in the symphysis, you can use the 3.7, and they go direct. Let's take a look at this implant. Has a 2.5 millimeter machine neck, 5 millimeter wide platform, internal hex to screw it in, a retentive groove so that we can give you a snap comfort cap and snap transfer with the implant. And this is the Go Direct implant. One piece implant, 1.5 millimeter neck, an extra 0.5 millimeter there, so it's really 2. This has internal threads, so that if you need to convert it to a different type of abutment, you can. So it's a one-piece implant that can be converted to a 2-piece. We have ball abutments, we have multi-unit abutments that'll screw into that, we need our tool to screw it in. It's stronger than the locator tool, and this comes in 2 different neck heights. So here is the screw-in direct, 3.7, 4.7, 5.7. There's a variety of copings available. Let's look at the packaging, what comes with this implant. You get the implant suspended on a orange carrier, which is the transfer. There's also a white carrier there and a snap comfort cap. and a 2 millimeter abutment if you need to extend the height from 2.5 to 4.5 to 5.5 with the comfort cap. If you use the extender, use the white transfer. That will tell the lab technician which analog to use. So we have plastic and gold castable. We have all plastic. We have titanium for welding, gold for soldering, and we have temporary abutments for teeth in a day. Here is the Go Direct one-piece implant. Comes in 3, 3/7, and 4/7. Starts only at 10 millimeters to 13 millimeters and 2 different collar heights. This surgical 3D graphic video will demonstrate the placement of 2 Go Direct implants in the symphysis. The 3.0 and 3.7 are the most popular diameters for this application. Starting with the 2.3 pilot drill, place 1 implant in the lower cuspid area. Place a guide pin into the pilot hole and use that to parallel the placement of the second Go Direct implant. Absolute parallelism is not essential, but they should be within 10 degrees of divergence. Enlarge the socket with the 2.8 step drill in soft bone for the placement of the 3.0 implant. In soft bone, you could actually place the 3.7 implant in the same socket site. You can use the crestal bone drill to enlarge the socket to the 3.2 diameter for placement of the 3.0 implant. Here is the vial with its 2 tear-off labels. And this shows the 3.0 diameter 13 millimeter implant suspended on its carrier, which can also serve as a transfer. Carry the implant to the surgical site. You could have a 2-piece implant with a GPS abutment or the 1-piece Go Direct implant, and essentially they'll perform the same functions. The carrier of the Go Direct implant serves as a transfer, so it should be preserved. Use the special insertion tool that fits into the trilobe on top of the implant. Ratchet it to place, leaving a couple millimeters projecting above the crest of the bone. If the tissue is thick, you may use the 3.5 millimeter collar implant to extend through the tissue. But usually the implant with the 1.5 collar, which actually is 2, counting the unblasted undersurface, will suffice. Snap on the comfort caps that come in the package and suture. At this point, if you wanted, you could attach those soft comfort caps to the underside of the denture to start to give some stability to the prosthesis. Here we see that we have a 1.5 millimeter collar and a 3 millimeter collar with an additional 0.5 millimeter in the flare. For the 13 millimeter length implants, stop at the 13 millimeter line on the drill. If you went up to the 14.5 millimeter depth, which is halfway between the 13 and the 16, you would seat the more of the collar length in bone. This is showing the placement of paralleling posts on the implants just to verify that you're within 10 degrees. You can be as much as 20 degrees divergent and the cap attachments will still work fine. That's 10 degrees pointed in either direction, but preferably these should be as parallel as possible. If you want to lower the height of the snap transfer, it can be cut off with a scalpel, just to make the impression procedure easier. Inject some impression material around the plastic transfers. And the snap transfer will pull with the impression. We also have open and closed tray transfers made of aluminum for these implants. You'll then insert the abutment analog into the snap transfer and pour up the working cast. Use a spacer and the metal housing with a non-retentive black insert. Add some acrylic. Form a base plate for the fabrication of a standard occlusal rim required for taking bite registrations. In the mouth, you'll establish the vertical dimension and make a bite registration. Mixing stone using standard procedures. You will mount the working casts on an articulator. To prepare for the setting of denture teeth. After the opposing model and the working cast with the occlusal rim are mounted, denture teeth can be set in the wax of the occlusal rim, returned to the mouth for a try-in to verify aesthetics and occlusion. The base can then be processed in acrylic, and an appropriate retention insert can be inserted into the metal housing, whether it be 1.5, 3, or 5 pounds of retention. The metal housings can also be attached chair side in a existing denture. Seat them in the patient's mouth attached to the implants. Add some cold cure acrylic after hollowing out the appropriate section of the denture, and just hold in place until the acrylic sets. Verifying that you've not opened the vertical bite. then remove the non-retentive plaque housing and insert the desired nylon retentive sleeve. My background is prosthetics. I've got a master's degree in prosthetics from Indiana University, and the opportunity to bring new and better prosthetic components to the market is something I really enjoy doing. Zest has really been the dominant abutment for overdenture attachments, and when I came out with the Go Direct implant, I was buying their attachments to go with the Go Direct. When they stopped selling it to me because we were competition, I went ahead and made an abutment system that is compatible with their attachment, plus we make our own attachments, and we provide the attachments free with the abutments at about a 40% savings over Zest. Plus we make a 15 and 30 degree angled abutment as well. There's a lot of money being spent on custom zirconia abutments. But if I can give you a straight contoured with two different collar heights, at an 8 degree and a 15 degree angled zirconia abutment, and if you can index the placement of the implant so that angle is pointing in the right direction or the contour is pointing in the right direction, you can get away with a stock abutment. Just grind it in a little bit. $120 versus $250 or $300 for a custom. We also sell the metal base for about half that price, and labs can buy this to make custom abutments. Better than having an all zirconia, which can fracture. This is on a metal base, and the screw tightens down on the metal, not on the zirconia. This is just showing how we can mass produce these. Because it's stock, we can make 54 of these abutments in a 2-hour period. Then we fire them, and then we cement them on with light cure resin with only a 0.5 millimeter of a margin. You can see the precision fit here. Compare this to Nobel at $285, where the screw, when they have a metal base, the screw tightens down on the zirconia still. So we think this is simply a smarter way to do it. Now, we make attachments for the GPS that grab the outside of the abutment, like Zest's extended range. But I'm also making, and we should have it out by next month, a ball attachment similar to the old Corvent attachment that I developed in 1982 or 83. And this will snap in, and it can move vertically and rotate. So when I designed our abutments and now the Go Direct implants, I have space here for this ball to move up and down and rotate. So this will give you vertical stress braking and rotation. And here's a throwback, my 1983 Corvent patent. Tens of thousands of these were done, and these balls are well protected so they don't wear out. All that's really changed here is I used to have a spacer that would hold this up when we attached it to the denture. Now we have the plastic in a metal housing, and we'll let the plastic hold it up, and then as the patient bites down, it spreads out. So another view of this, rotating, and this is what it'll look like. The same metal base that takes the attachment we now have that snaps over the outside. We'll take these ball attachments. Let's talk about the Swiss plant. Now we changed the name to Swish plant system. Straumann objected to us saying Swiss, so I said, okay, I'll call it Swish. It means elegant. First, we made one that I thought was a significant improvement on theirs. It's straight, and then it's tapered. I put a light blast on the neck so you could leave it tissue level or drop it down. We put it on a fixture mount that can be shortened, and you have a snappy abutment. So that was the Swiss plant implant. And if you take a look at what Straumann offers, their narrow diameter implant has an external octagon, or this narrow one, which has a history of breakage, has too wide a top. Then here's their 2.8 head and 2 millimeter head, and finally they came out with what they call the taper effect, which is just tapered at the top for extraction sockets, not designed to spread the bone, and now they have a bone level implant. The president of Straumann asked me what I thought of his bone level implant, and my answer was underwhelming. He said, well, why do you say it's underwhelming? I said, well, what do you got? You don't have microthreads, you don't have a tapered implant, you don't have a self-tapping groove, and you got an internal square. I mean, what's the big deal? Now, their fixture mount has some real limitations to it. They have an internal octagon in the implant. I licensed them on that in 2000. But I would not let the license include a hex, because I knew the problem with an octagon is you put torque on it, it's too close to being round, and the fixture mount will rotate in it and lock in. So they have an octagon covered under my original screw vent patent. So therefore, their fixture mount is the screw is what is turning the implant. The more torque you put on it, the tighter that fixture mount is getting in the implant. And when you want to remove it, you have to use counter force. I think we show it here. We'll show that in a minute. Their unique selling proposition is they package their implant in sterile saline. We sell the saline separately, and they charge $60 more for that. And then when they went to a small diameter implant, they didn't want to admit that they needed an alloy like everybody else has been using for 20 years, so they came up with their own alloy, which they call Rock Solid, which is a zirconia titanium alloy, which I predict is going to be too brittle, and you may see some long-term failure with that. Anybody could use that alloy. It's approved by the FDA, that type of alloy, but nobody wanted to use it because the aluminum, vanadium, titanium alloys used by the orthopedic history have a 40-year history. So there's their implant in water. So this is their implant. Then Paragon came out with the Swiss Plus, which is still sold by Zimmer. Then I came out with the tapered Swiss Plus, put a fixture mount on it that can be shortened to be an abutment, brought the threads closer together. They then came out with their taper effect, which brought the threads closer together, still no cutting groove. And then in 2008, we introduced the Swiss Plant implant with all-in-one packaging, including a cover screw and healing collar. The prosthetics is compatible. It has an internal square and an internal octagon. So our fixture mount engages the square to turn it in, and that's why we can put torque on it, leaving the octagon alone for the abutments. And with a lightly blasted neck, it can be used tissue level or drop down bone level. So here we have the Straumann, we have the Swish, we call it Swish Plant, and the new one, which I call Swish Plus, which is 100% compatible with Straumann. Same thread pitch, single thread. The threads do get progressively deeper. I have put a cutting groove, and I added micro grooves, and I carried the blast halfway up the 2 millimeter neck. This has a number of features, as we talked about, the micro threads, micro grooves. With the blast running up, you can drop it another millimeter in the bone. We're also coming up with a bone level Swish Plus, which we'll call Swish Plus 2. It'll have the same body, same micro grooves, and we'll have a conical connection going in with all of Straumann's drills. So here is the packaging on the Swish Plus, a frictional fixture mount made of titanium that fits into the square. So what this implant has is it has the octagon for the same compatible abutment connection, and it has the square inside, eliminating the need to use that anti-torque device when you're unscrewing it. Definite improvement. Here's the body with the blast running halfway up the top and the micro grooves. And here is our abutment on a Straumann implant and the Swish Plant showing the light blast on the neck. A study done by Boozer and others actually carried their blasted surface, the Straumann blasted surface, all the way to the top, and then documented that you get less bone loss when that textured surface is in the soft tissue or when it's pushed down in the bone. So if you put the blasted surface level with the bone, you had 0.63 millimeters of bone loss. When they dropped it below and the machine surface was in contact with the bone, 0.69. But when you left the blasted surface above the bone, you got actually 0.37. Or when you drop the blasted surface below the bone, it also preserved crestal bone loss. So having a light texture surface in the soft tissue is not a bad thing. Full line of abutments. We have our abutments kitted. Here's the Straumann type solid abutment, $100 versus $280 or $238 for their kit.
This video will demonstrate the Swish system of Straumann compatible implants. This picture shows the Straumann implant being replaced by the Swish Plus and Swish Plant implants. The Swish Plant is tapered. It has a dual texture on the surface of the neck. It has many threads, self-tapping groove, whereas the Swish Plus has half its machine neck covered with the blasted SBM surface, and it has micro grooves, has the standard Straumann threads, and also self-tapping groove. Both of them have exactly the same internal connection, an internal octagon compatible with Straumann's system, plus a square that's been broached in the flats of the octagon to allow engagement of the fixture mount. They both come in a variety of lengths and diameters. The Swish Plant comes on a fixture mount, titanium fixture mount that can be shortened to be a snappy abutment. The Swish Plus comes on a titanium fixture mount that is just used as a carrier. That carrier is compatible with Straumann's ratchets and insertion tools. Here's the packaging for the Swish Plant implant, suspended on its titanium fixture mount. Also in the package is a cover screw and extender, and a snap-on comfort cap if you were to shorten the fixture mount chair side and use the comfort cap to temporize the restoration during healing period. There's the cover screw and 2mm extender in place. The Swish Plus packaging is quite different. Here we have a titanium frictionally retained fixture mount. You also get the cover screw and the extender. Let's demonstrate the placement of the Swish Plus implant. In addition to using the drills offered by Implant Direct Cybron, the 4.1 and 4.8 implants can be inserted using Straumann's drills. For 12mm length, start with the 2.3 Implant Direct Cybron pilot drill to the 12mm depth. Follow that with a paralleling pin to verify the correct angulation has been determined. Then the 2.8 intermediate drill. The reverse side of that paralleling pin will fit into the 2.8 socket. For the 4.1, you would then use the 3.5 drill to the 12mm line. The implant is self-tapping, but in dense bone you could either use Implant Direct's crestal bone drill to enlarge the few millimeters near the crest,
or you could use Straumann's bone tap. That crestal bone drill, if penetrated farther, would flare the crest to accommodate for the neck. Here we see the frictional split in the fixture mount that suspends the implants. There's also 8 dots that indicate where the flap on the octagon is located. You can insert this using the square ratchet from Implant Direct or the insertion tools from Straumann, or a set of insertion tools also available from Implant Direct that fit frictionally onto the O-ring. Here's the handpiece insertion using Implant Direct's fixture mount drill for the Swiss Plus implant. Carry the implant to place. Rotate it at slow speed so that it's 2 millimeters above the crest, leaving 1 millimeter of blasted surface, or in the more aesthetic zone, you could drop it another millimeter or even flush with the bone if you had used the crestal bone drill to create the flare. This is indexed with one of the dots facing the buccal. The importance of that is shown here. Implant Direct indexes its abutments so that the contour of the margin faces towards the flat of the octagon and the angle of the abutments faces away from the flat of the octagon. So you can use these pre-machined abutments and get them pointing in the right direction by indexing the implant at time of placement. The underside of the vial holds the cover screw and 2 millimeter extender. You can use Straumann's tool or Implant Direct's 1 1/4 millimeter hex tool. The cover screw is double broached to accept either. Tighten it with finger pressure and suture for 1-stage healing. If you want to bury the implant for 2-stage healing, you could just add the cover screw, leaving 1.5 millimeters or so above the crest, or you could drop that implant level with the bone. With just the 2 millimeter extending above the bone, usually just the cover screw alone would be adequate to maintain the tissue opening. When placing the implant using Straumann's ratchet, carry the implant from the vial to the site using the ratchet and adapter that Straumann sells, and Implant Direct also sells an adapter like that for the square insert of our ratchet. You can insert that conversion unit and then carry the implant on our ratchet. Another option involves just hand carrying the implant to the surgical site, starting the threading and then slipping our square ratchet over the top to engage the square partway down the fixture mount. Again, lining up one of the surgical indents to the buccal for indexing of the abutments. Another option is to use the Straumann ratchet or the square ratchet with Implant Direct's SPRI adapter. This shows the abutment kit for the solid abutment available from Implant Direct for a price of $100. You can remove the frictional fixture mount, insert the one-piece solid abutment with its retentive groove just above the shoulder, tighten it down to finger pressure, use the snap transfer that comes with the kit, line up the projection with the flat of the abutment. You'll see there's a corresponding flat on the inside so you can feel it, lock into place, snap it down, make a transfer impression. This could be done after suturing the tissue if you prefer. Then place the comfort cap that comes with the kit on the abutment. Check for the retention. This is not a very flexible material, so you may have to rotate the comfort cap so that the flat does not perfectly align, and then press down for increased stability. And then allow the implant to osseointegrate over a couple-month period. You can insert the abutment analog into the snap transfer, again aligning the flats. Pop it in place. Put some soft acrylic to eliminate any undercuts and to create a replica of the soft tissue. In the kit comes a castable coping with 2 slots to stabilize the coping on the abutment analog. You flow some wax into those slots, then do your wax buildup, cast that in ceramo metal, bake the porcelain on that crown, and then back in the mouth you remove the comfort cap and check the occlusion after seating the crown and before cementation. There are a wide variety of abutments available with the Swish system that all fit Straumann implants. Here we have the 2-piece and then the 1-piece straight snappy abutments, a straight contoured abutment with 2 different collar heights, a zirconia straight abutment also available in 2 different collar heights on a metal base, an angled titanium abutment, 2 angled zirconia and metal abutments, 8 and 15 degrees, a gold abutment with a plastic castable sleeve, a titanium temporary abutment used for retaining dentures, a plastic temporary abutment, a plastic castable abutment, a multi-unit abutment for fixed attachable restorations, the GPS abutment for overdenture attachments, and the ball abutment rounds out the Swish prosthetic system.
Let's talk about the Replant implant. Has the tri-lobe connection. It's made of titanium alloy. The walls get quite thin here, so alloy is important on the 3.5 and 4.3 implants of this type. I have a patent issued on the double tri-lobe. That's how I was able to get around the Nobel patent and offer Nobel customers an alternative, a reasonably priced alternative. So it comes in 3.5, 4.3, 5, and 6. Mistake that was made is when they went to the 4.3, they should have kept this platform so the walls would be thicker. Instead, they went to a wider platform, so the walls are very thin on both of those implants. So here's ours compared to the replaced. This has grooves. Ours has micro threads. Nobel's is not self-tapping. Ours is. Ours comes on a titanium fixture mount that can be used as a transfer and temporary, and ours is made of alloy for greater strength. And here is a Replant next to a Nobel Replace. For all intent and purpose, you can't tell the difference. We have our own surgical trays, or you can straight drills, or you can use Nobel's tapered drills. Now, Nobel has come up with a number of new implants over the years. We have the Nobel Perfect, which they bought from Dr. Peter Worley. That's already off the market. You can still buy abutments for it, but you can't buy implants. Then you got the Nobel Direct, developed by Dr. Drago, an oral surgeon in San Diego. If you search under class action lawsuit, this one's currently being sued because they reported a lot of bone loss in Sweden, and that got around and led to litigation. And here you have the Nobel Active implant, which they bought from an Israeli company for $95 million. I turned down buying that company for $6 the year before. So I went over there, and he was doing $6 million a year and netting $3 on an implant that was selling for $60. And I took a look at the implant, and I just saw that it was getting the body made in one European country and the abutments in another. And I showed you, yeah. So it's just the quality was just not there. Anyways, Nobel bought it from them, and then they changed the implant. This is still being sold in Israel under the original SPI, but in Israel it's a better implant. They left the 45-degree bevel that this guy had copied from the screw vent because that's how he got his start. And it has a cutting groove, but the cutting groove is working in the right direction. The sharp edge is over here, so as they're screwing the implant in, it self-taps. If you go to the Nobel Active, they'll put the cutting groove over here to help you unscrew it, because this implant tapers so dramatically that it'll jam into the bone. Now they tell you don't use it in dense bone, but before they didn't. So you needed a way to unscrew it. And then they wanted to chase Astra, so they put a conical connection on it, getting away from the 45, going to 78, push the hex farther in the implant, and as a result you need to take x-rays to see if the abutment is seated. We'll get into that a little bit more. So here is a Nobel Replace implant next to a screw plant. The wall thickness here is 18 thousandths on a 3.7, and this is only 6 thousandths on a 3.5 and only 12 thousandths on a 4.3. So those walls are very weak. It says right on the package, did not exceed 45 Newton centimeters. You don't know you exceed it until it breaks. And here is a broken implant. And somebody had to grind it out. We have a full line of abutments. All of our abutments take the Nobel Unigrip tool. So they're double broached to take our 1 1/4 hex tool and the Nobel tool. We also have the Replus and Reactive implants. These are the ones that have the tapered body like the Legacy and the screw plant, but with a tri-lobe connection. The Replus comes on a fixture mount. When you cut it off, you have a snappy abutment. Gives you platform switching because we're going from 3.7 to 3.5, 4.7 to 4.3, 5.7 to 5.0. Here's a case with 2 implants. These are HA-coated Replus implants. Fixture mounts with the flat lined up to the labial. Cut off the top of the fixture mount, attach the abutments, snap on the comfort caps, and suture the case. And this is just the snap transfer procedure. Nobel Active, it says for experienced users. That's a euphemism for the darn thing may not work unless you're good or lucky. And then it made the Nobel customers have to switch platforms. By the way, Nobel is now going to be bringing the Nobel Active platform out on the Replace implant, not getting away from the tri-lobe, but offering an alternative which allows them to then raise the price and sell you their more expensive Nobel Active abutments. Again, they've got the cutting groove going in the wrong direction, very sharp apical end. Now they're finally saying in indications and solutions for cases involving soft to medium bone. Well, how do you know what bone you're going to get into until you start getting into it? Of course, in the maxilla, you're not going to get into dense bone, but the lower you can. So now you got an implant that they didn't tell you to begin with it couldn't be used. I know a dentist that locked it into dense bone and had to cut 2 of them out with high-speed drills because when he tried to unscrew it, it stripped the hex. I bring this up just to emphasize that companies that their unique selling proposition is, well, we've done more research, we have more published articles. Here's the prime example of a company that hasn't thought out their designs and launched that implant with less than I don't know if they had even a year research on it. So here's the reactive implant on a fixture mount. So you can see the Nobel replace the threads blunt down to nothing. Here's our Replus and Replant with the standard V threads. Our reactive where the threads get progressively deeper but still a round end. And the Nobel Active where there's a wide space among the threads, very deep, very sharp. The wider and deeper the threads just makes more room for the bone to push in there. It doesn't really add to stability. You get more stability initially by spreading the bone with an implant like that than you do with this. This will give you more surface area and will go into a smaller hole. So we have an even taper, and there's flares out and then tapers back, leaving a defect in the crest of the ridge with micro grooves. This is looking down at the top of our Legacy 3 implant, a very clean connection, looking down at the top of the Nobel implant where you can see burrs on that implant. If this weren't true, believe me, if I showed it, they'd be suing me. So this is an implant we bought and documented and took pictures of. And here's a case done with our reactive implants. Straight drills, screw the implant in, there's the fixture mount on it. Shorten the fixture mount. Don't use a diamond, use a carborundum. And temporize it. Now, if you're going to do a sinus elevation, do you want a round end on the implant, or do you want an end that looks like this? I think I know the answer. And where is this tapered to preserve crestal bone? You can see there's crestal bone loss around these implants. So you have the Nobel with the trilobe. You have our Replant, same body shape, double trilobe. And we're coming up with a new one called the Interactive. This will be the body of a Legacy 2 with the conical connection of a Nobel Active. And for those of you that can't decide whether you want micro grooves or micro threads, we've got them both on this implant. This is the body of a Legacy 2, so it's very aggressive. This will go in with Nobel replace drills or Legacy drills. It comes in a 3/7, but with those aggressive threads, you can prepare it for a 3/5 Nobel replace and screw this in. There's the micro grooves and micro threads. And here's the implant. 3 cutting grooves, long cutting groove, and a conical connection for those people that buy into that marketing story. There's only going to be 2 platforms. The 3/7 and 4/3 have one, and the 5/7, I think, has another connection. So there'll be 2 connections. Now, here's the Nobel Active. They tapered this at 78 degrees, which drops the hex 0.88 millimeters below the crest, whereas the screw vent that I developed in '86, the Legacy connection, 45 degrees, it's only 0.32 till you get to the hex. So now you can feel the hex a lot better. Also, you don't have this long, thin neck that had a potential for fracture as well, especially in pure titanium. So just comparing the 45 degree versus the long bevel. One of the problems that results is the screw will engage the threads before the abutment is fully seated. So Nobel gives you these x-rays and says, well, that one isn't seated and that one is. And here's why. So you're supposed to look at x-rays and figure. Here's another one. This one isn't, on their transfers, they finally put a notch on it, but they can't put a notch on the abutment. And here was an article that was published showing one of those implants, and I called the guy up and I said, you know, your transfer isn't seated. He didn't know, and you can be sure the abutment wouldn't fit. And here's an actual Nobel active abutment with this long bevel and short hex, and you can get it off angle and it won't seat. And here's our internal hex. You can't help but feel that it's seating. The whole idea of internal connections is to eliminate the need for x-rays, so you can have a tactile sense when it's down. So this has got a short bevel, this has got a big long bevel. Now, I started out just to make a set of abutments for the Nobel Active, and then I said, well, I might as well make the implants. So I am making a set of abutments that eliminates the need to take the x-rays. We lengthened the hex, we put a lead in there that'll straighten it up, we shortened the bevel a little bit, and we're delivering it on a plastic carrier that you'll position it, feel the hex goes in, and then run the screw through the center of the carrier. The screw will be held in there because there'll be internal threads in the abutment. So it's not coming out of the abutment. Once you get the abutment seated, you run your hex tool through and screw the abutment in. So you'll be able to handle it and know that it's seated. I call it the Nobel Fix abutments. And here you can see the internal threads, this little lead, and we're developing a carrier that'll really help. So on the team approach, choose the right implant that makes it easier and more profitable for the restorative doctor, educate them, provide them free transfers, and abutments is always nice for a surgeon, and we give that free with most of our implants, but if you had to buy it, they're not that expensive. We've got a whole system for communicating what implant you put in, solves the communication problem.
This video shows the team approach prosthetics for the trilobe implants. The surgical specialist should provide this to his or her restorative dentist. The trilobe implants come in 3 implants with different fixture mounts. The Replant comes on a fixture mount that can be used for a temporary abutment or for a transfer. The Replus comes on a fixture mount that can be shortened to be a snappy abutment. And the Reactive comes on a fixture mount that can be shortened to be a preparable abutment. The surgical specialist would attach the healing collar, suture. He would then place the fixture mount that came with the implant that he had inserted into the vial along with its screw. With each implant shipment comes instructions for use, and in that packet are 5 patient labels. The surgeon would then write the patient's name on this label, the referring doctor, and the tooth number of the implant. Place this on the implant vial containing the fixture mount, being sure not to cover the second tear-off label that can be used by the restorative dentist for his chart. Send this implant vial with the fixture mount to the restorative doctor, along with a downloadable letter that explains all of these procedures. The restorative doctor can see what the tooth number is, remove the healing collar. In this case, it's the fixture mount for the reactive implant. Can be attached, used as a transfer. Also, the Replant and Replus fixture mounts can be used for transfers. And also, there are closed and open tray aluminum transfers that are available. Seal the opening with a cotton pellet and some putty.
make the impression. This is a closed tray impression procedure. Long screws are available for this fixture mount if you wish to turn it into an open tray transfer. Using either the 1 1/4 millimeter hex tool or the Unigrip Nobel tool, you can remove the screw from the fixture mount, reinsert the healing collar, then the restorative doctor would send the impression along with the transfer and lab instructions to the lab, where they will attach the fixture mount to an implant analog, insert it into the impression, lining up the flats with the flat in the impression. They will apply a soft tissue replica material to eliminate any undercuts and to simulate soft tissue. Pour the model in dye stone. The lab can then remove that and select from a variety of abutments or modify that abutment. Here we see that the Replant system contains straight contoured margin abutments, straight zirconia abutments in 2 different collar heights with contoured margins, an oversized lab abutment that can be prepared to any angle or margin position, a snappy abutment that comes with a snap-on comfort cap, angled titanium abutments in 2 different collar heights, 15-degree angled abutments, angled zirconia and titanium abutments available in 8 and 15-degree angles, gold abutments for fabricating custom cast abutments, plastic temporary abutments that can stay in the mouth for up to 6 months, plastic castable abutments, non-engaging titanium abutments for converting dentures for teeth in a day procedures, these multi-unit abutments for fixed attachable restorations, GPS overdenture attachment abutments compatible with the locator zest attachments, and finally the ball abutment for overdenture attachments. For most cementable restorations, the lab technician will be able to use the fixture mount of the reactive implant. He'll attach it to an implant analog, section off the square part using a carborundum disc. This abutment now has a 1.5 millimeter high horizontal margin. The abutment will be reattached to the working cast, tightened down with finger pressure, and prepared for any minor angle corrections and to adjust the height of the margins. The hole will be sealed to allow waxing of the metal framework and fabrication of a ceramimetal restoration. Restorative procedures will then simply be to remove the healing collar, attach the lab modified abutment, tighten to 30 Newton centimeters using a torque wrench, put a cotton pellet and some putty or wax to seal the screw chamber, try in the crown, check for occlusion, and cement the restoration. So we've got these downloadable thank you letters with the links to the appropriate video, a full explanation. We even have, if you want to open a shopping cart account for your restorative doctors, you can choose a letter that says, I've opened an account, your passcode is this, order whatever abutment you want if you don't like the one that came with the implant, and it'll be shipped to you and billed to me. We will call you before we ship it, but that's a great way to provide a service. Spectra system, we've talked about those. There's 6 implants. We've looked at all of those. Screw plant, just in comparison to the Zimmer implant. Just in 3 diameters, though. We haven't broadened those products. You got the one piece, or you could add an abutment, all in one packaging. Here's a case. I think this was Dr. Cavallero's case. And he's able to use these fixture mounts. Here's another case. Placed a 5.7 10 millimeter implant. Cut off the fixture mount, put the snap comfort cap on, waited until it healed, and then, so it's healing one stage, it's out of occlusion, and wait till it integrates and then load it. 3i implant surface and platform switching. Let's talk about platform switching. First of all, 3i has this acid etch surface with 2 micron pits. Now they dip it in calcium phosphate, so you get a few granules of HA in the pit. Doesn't add to the surface texture. Here's the first platform switching implant, the Corvent. Then you got 3i connection. Then you've got Astra's platform switching, our Replus's platform switching. You could put a legacy abutment on a screw plant and have it platform switch. But platform switching itself will not stop bone loss. Here is a reactive implant, and you see it's platform switching, and you still got the bone loss. Maybe the margin wasn't sealed. Maybe the ridge was just thin. Now we have Dentsply just acquired Astra. I don't know if you've heard of this, to go with its ankylose implant line. They paid $1.8 billion, and they also got a urology division with it. So nobody really knows what they paid for the implants. Whatever they paid, they overpaid. Here's the Astra system. It's a straight implant with microthreads to the top, and then they have these that flare at the top for extraction sockets. And it provides good stability with this long conical connection. So it really stays sealed, as does our 45-degree bevel. But the problem is you now have a long conical connection with very thin walls. So what do you think is going to happen when it overloads? The wall pops out. That's a piece of the titanium. So these microthreads sure didn't stop bone loss on this implant. And here it is with the fractured implant. And they also have a history of screws coming loose. Here's another fractured one that somebody sent me, because they make it out of pure titanium. If you lose the bone down to the threads, it can fracture. Their abutments, because they're afraid of over-torquing the abutments, they have torques from 15, 20, 25. Who wants to figure out how much torque you need to tighten the abutment? All of ours are 30, and you're done with it. The implant can withstand it, the screw can withstand it, and it'll stay together. When you're tightening this 15 degrees because you're afraid of over-torquing and breaking the implant, you could end up with loose abutments. So Dentsply ankylose implant placed subcortical. The ankylose says, oh, we preserve crestal bone. No, you don't. You drop the implant below the crest of the ridge. You've already given up 2 millimeters of bone contact. So I fudged this picture to show that you could have had that much more implant in contact with the bone. They need to do this because they've got a Morris taper tap-in connection. So they got a long abutment, and they need to drop the implant to get the height of contour of the abutment below the crest. like bicon. And sometimes you need to use a crestal drill to cut away the crest just to get the abutment seated. Here's another one somebody sent me he was so proud of, and he dropped it way below, and I sent this back to him. I said, this is the way it should be, and the guy is now using our system. So I don't know how Dentsply is going to be selling micro threads to preserve crestal bone on one hand and ankylose, drop it below the crest on another. That's talking out of both sides of your mouth. Here's another case of Dr. Cavallero's, the external screw plant, which we had on the market before the Legacy. Are you using mostly Legacy now?
Yeah, well, that was a natural progression.
Yeah. He shortened the abutment. There's the comfort cap. There's the transfer. Another case, put two of them in, screw plants, shorten them, snap transfers. There's the transfer in the impression, the snap comfort cap. Here's the abutment analogs. You leave the abutment in the mouth. You now have abutment analogs that replicate the top of that abutment for the working model. And was this your case or somebody else's? This dentist made a very nice temporary. He used the comfort caps, splinted them together, and made a beautiful temporary in the posterior. You can see the tissue hasn't healed yet. They're coming for me. Okay, immediate placement. Yeah. Here's a case done by Ed Mills. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Anybody who puts 11 of my implants in one jaw is okay in my books. And was able to use 11 of the free healing collars. Here's a case done in Israel. Did 10 of the implants, all the fixture mounts shortened, the snap comfort caps, the transfers, all 10 of the implants integrated, and can't really tell what the final prosthesis is, but that shows that this system works even in complex cases. Here's a one-piece screw direct implant. It comes in 3, 3, 7, 4, 7, 5, 7. Again, 10, 13, and 16 lengths. Comes with the snap transfer and comfort cap. Here's a congenitally missing lateral, and the dentist put it in. He prepped this a little bit, put the temporary on it. These were two done 5 years ago on my brother-in-law, and I can tell you they're still in the mouth, holding a 3-unit cantilever bridge. Here's a nice immediate load case, placing this implant. There's the implant, comes suspended on a transfer, placed the implant, temporized it, did the transfer impression. There's the abutment analog into the transfer, and it went from this to the final restoration. Screw indirect, let's look at a couple cases there. We sell this titanium sleeve that comes with 2 screws in it. If you use the extender, you'd use the short screw. If you didn't use the extender, use the long screw. So we give you both screws just so that we'll have it. See, here's the one with the extender in it. Oh, and if you want to take a look at savings on a cost basis, well, here, it's right here. $925 to do 5 implants, and with no bell, you'd be at $3,600. That's a 74% savings. That's the difference between a patient being able to get this done or not. You hear so much about all on 4. Well, you can angle these 40 degrees divergent and still seat the framework. So here's a case for them going in. Leave the 2 millimeters, 2.5 above the crest, the comfort cap, beautiful soft tissue healing, snap transfer. That's where the bone is. There's a close-up of the implant. So when you look at this, you have to say, why would I use a two-piece implant? Why would I put an implant in, buy an abutment and attach it, and have that junction at the crest of the ridge when I can do this all with one implant? And this was restored with a gold bar, and I don't know what kind of attachments those are. ERA, okay. To me, this is overkill. 4 implants, you still have an overdenture. You could have put 2 locators in there and accomplished the same thing. If you're going to do 4, do 5, cantilever back, make it totally implant supported. Here's another case done by a young dentist. She put 5 of them in. This is one of her first cases. The comfort caps, did a beautiful job putting it straight, used open tray transfers, fabricated a cast bar with cantilevers back with O-ring attachments. This was placed within 48 hours, and here it is 2 years post-op. Beautiful case. And one other one, teeth in a day. Dentist made a surgical guide just to help locate where he wanted his implants mesiodistally. There he put 7 implant in, could have got away with just these 5, but to put 2 distal, sutured. Then he put blue mousse inside the denture, seated the denture just so he could see where the indentations of the implants are, drilled the holes, seated the, attached the titanium sleeves, seated the denture over that, attached those sleeves to the denture, and shortened the sleeves, and the patient walks out that day with a screw-retained overdenture. A little trick, which I'll show to you on a case, how to take the final impression at the same time. Legacy 1, 2, 3. Here's Zimmer. All their marketing now is with somebody with their finger up in the air saying, "I am Zimmer. I am Zimmer." It says, I know that action speaks louder than words, but I want you to have this in writing. I am committed to your success, to showing you that Zimmer stands for quality, service, and innovation. So I sent this to the president. I said, apparently Zimmer doesn't stand for good grammar. This is an incomplete sentence. So here is the screw vent. Top thread is down here. Screw plant, top thread's way up here. Here is the screw vent. Thread stop there. You got 1 millimeter of a machine surface. This is blasted to the top with micro threads. A fixture mount that can be shortened to be an abutment. A fixture mount that's just a transfer. Yes, they have friction fit connection. I developed that in 1993 or 4 when screw loosening was a marketing issue. But we soon learned that internal connections torque down to 30 Newton centimeters solves the screw loosening problem. And the last thing you want to be doing when you're doing immediate load is put the implant in and then put the abutment on and have to torque the abutment 30 Newton centimeters just to get it seated. So I didn't include friction fit this time around. It isn't necessary. It requires a special tool to get the abutments out, and with the kind of precision we can get today, it's just not necessary. Here is Zimmer's latest information from their website. And I put this in a newsletter. Zimmer Dental finally updated the screw vent developed in '99 by Niznick. Zimmer added micro grooves and extended the HA blasted surface to the top. Zimmer used this change to raise the list price from $386 to $396. Now who's making clothes? And if you click this, it says who's the discounter. This will take you to our website where we have about, maybe 20 or 30 records of discounts that Zimmer did, another 20 or 30 or 40 that Nobel did. So people tell us what their deals are. If they're going to discount, let them discount to everybody. So they've added these micro grooves. And then I say Implant Direct launched Legacy 1 in 2007, also developed by Niznick. It offers both surgical and prosthetic compatibility with the tapered screw vent, as well as the same type of HA blasted surface. From the inception, the Legacy 1 extended the blasted surface to the top and provided its patented micro threads, not micro grooves, for added stability. The only price change in 4 years has been to lower the price on the Legacy 1 from $150 to $125. And this shows you the stability that you're getting from micro threads. And this is the outlines of the implants, Legacy 1, 2, and 3. And this is a Legacy 3 next to a Legacy 2 with its more aggressive threads. Here's the fixture mount on a Legacy 2 and next to a Legacy 3 with its fixture mount that can be abutment. I'll skip over that. And a full line of prosthetic components. Here's the packaging on the Legacy 3. Implant comes on this titanium fixture mount. It's a multifunctional purpose. It can be shortened to be a preparable abutment. It can be used as a transfer and a cover screw and an extender, 2mm extender. And there's the Legacy 3 with its 6 diameters. And basically this is showing what the video showed. You seat it, you shorten it, you prepare it, you seat it again, or you can use it as a transfer and prepare it on the working cast. And nice surgical trays, well organized. Here's the 7mm implant. We've shown that slide series before. Here's another 7mm below the sinus. 10mm one or 8mm. Very handy implant to have. Okay, mini implants. Let's finish with mini implants. You see 10 or 11 of them. They're not economical because you have to use so many of them. And they're little pointed things. Here they're going perforating. They're going lingual to the mental foramen, hopefully. Zimmer is now selling the ERA mini implant. There's some with balls. Now when Zimmer was selling the locator against the ERA, they did studies, showed the locator you could do 110,000 cycles versus the ERA at 3,500 cycles. Now they're going to put that attachment on a one-piece implant, and I don't think that's the wisest idea. So we've got a variety of small diameter implants. Here's a 3.2 micro vent 20-year follow-up. So you don't need rock solid from Straumann to do a small diameter. I've been doing them for 25 years. That's why it's called microvent. And here's the Legacy 3.2 implant. Overdenture treatment. Here's 2 implants with locator attachments. The locator has this hinge action in it to help align things. But you can accomplish the same thing by just like a ball abutment by rotating around the top. So this is our attachment, and we can't have that hinge because it's covered by their patent, but I solved the problem another way just by making it rotate. This flexes out, and here it is rotating. This has got zest in such a dither that if you look at their ads today, they're naming us in all their ads. Beware, they don't have our patented feature, all at the same time that they're suing me for patent infringement. Do you believe that? Tell them, everybody, we don't have their patent feature, sue me for patent infringement. But we know that if we didn't have that rotating part, you don't infringe their patent. And then we made angled abutments, and we've got a full line. Our metal cap is more retentive, it's colored pink. We use a higher heat black spacer. You get all of this, transfer and everything for $100. And we got a full selection of them and a very innovative tool to remove it. As you tighten down the screw, it bottoms out on the metal and lifts it back. Here is locators at. If you're not using locator pivotal technology, here's a case for changing. Caution. GPS abutments and components don't have our pivotal. Well, here's graphs that we did with 50 cycles. Ours tracks right on the retention maintenance of theirs. It's ours and theirs. And there's their warning. So that's prompted me to run ads up against theirs now, which they won't like. Comparing side by side. We have an internal hex. They have 3 grooves to put it in. So you can put our GPS using whatever hex tool you use, or Unigrip or Straumann tool, without changing tools. And then we designed our abutments with more room here at the bottom to take a ball attachment. We're making hater bars now. We haven't gone to the market with it yet, but we're making hater bars with the GPS attachments at a reasonable price. There's a bar case we did. There's a teeth in a day using our bar and our implants. This is 4 legacies with GPS abutments, and these are legacies with GPS abutments as well. So the dentist put 4 of them in and buried them. Didn't have to do this. Then he put 3 mini implants in to stabilize the denture while he was waiting for his buried implants. Then he uncovered them and put the locator attachments on it. In the maxilla, he spread the ridge. He put 3 legacies on either side, did a nice job, and ended up with the denture with still a roof on it with 6 implants. That's a lot of implants to end up with a denture on it. Here's a dentist that placed 6 of ours, got them in a better position and could make a roofless denture. Now Nobel is getting into the act. They've made an extended neck on their implant. It just brings the trilobe to the top. It doesn't flare out or anything. And this is their idea of a 1-stage implant, just to extend the neck. So here is Go Direct 1-piece implants. There's 2 of them. It has internal threads, so if you want to screw in a multi-unit abutment or a ball abutment, we've got a whole video that shows the conversion. We even have an abutment that looks like this that screws in. Come in 2 different neck heights. Here's the abutment that would screw in to add more height. So all over 4 is going to be a viable treatment. It's 2 Go Directs and then 2 Legacy 2s with angled GPS abutments. Here's 4 Go Directs. Here's 4 in the lower with the comfort caps. Here's 2 that were used, 1-piece Go Directs to stabilize a partial denture. Here's 2 on either side for a partial denture. Here's 4 of them going in 3 millimeters. Here's 3 of them, which is probably all you need. And here's a case done flapless. Very narrow ridge using the 3 millimeter implants. I guess he thought he could feel where the crest of the ridge was and did a beautiful job placing those implants. He could have just laid a flap, flattened the ridge, and gone farther down into better quality bone. I think that would have been a more predictable way to do it. And here's a case, 5 screw-in direct implants. Again, a narrow ridge that the dentist should have flattened off, would have saved bone grafting and the exposure of the implant. Put the titanium sleeves on, drilled holes in the patient's denture, attached these sleeves, and delivered teeth in a day to the patient. So that's what he started out with, that's what he ended up with, and he could very well have flattened the ridge and put 5 in the symphysis and not flirt with the mandibular canal, although it's plenty of height there to do it if you wanted to. So we have the Legacy 3, 3.2. Congenitally missing laterals done by a surgeon with surgical stent, placed them beautifully. Can't do much better than that. Can't practice without a 3.2 2-piece implant. Another dentist did it with the endophile, positioned it, took x-rays, did it flapless, screwed in the 3.2 implant. There's the fixture mount, did a transfer for the temporary, I guess, and Here's the double hex platform. Then he took the fixture mount and prepared it indirectly, I think, and there's a nice single tooth case. And teeth in a day, we're using the screw indirects, using whatever implant you want at the top with our OD abutments and our angled OD abutments, 15 and 30 degrees. We use it with surgical guides. Here's a study done by Dr. Pedro Pena in Spain and 5 other colleagues of his. 421 implants, 373 were replants, 48 were Nobel replace. He had 13% failure with the Nobel replace. He had 1% failure with our implant. He attributed that to higher initial stability. Here's Nobel's angled screw receiving abutment. The screw goes through the center and another screw goes in that direction. This is ours where the base is angled. You screw in the base and then you screw on this top part into internal threads, sealing the screw inside the implant for a more natural contour. And here's 4 implants that Dr. Pedro Pena placed using our angled screw receiving abutment. Straighten out the distal ones, attach the titanium sleeves, drilled holes in the denture, and before he trimmed the flange of the denture, he blocked out the undercuts with soft acrylic, poured up the working cast, because that is, and he put analogs in here, because that's the most accurate transfer you'll end up with. They're already locked together in acrylic. So he sent the patient home with the temporary denture. Then he could make the final denture, which he used titanium sleeves, rib bond reinforced material, pink acrylic, and processed a denture without any metal framework, and that's the common way to do these in Europe. And this is another case showing they alternated Nobels and the Replant implants with 8 of them, and did a beautiful job of positioning these implants as part of that study. And then here's 5 Replus implants in the lower jaw. You can tell they're Replus because of the fixture mount, beautifully placed.